Hello and welcome to our next Shell Eco Marathon virtual learning session, today with Altair Engineering. My name is Norman Koch and I'm the Global General Manager of Shell Eco Marathon. First of all, I want to start off by thanking all of you for your flexibility and your understanding as we evolved the Shell Eco Marathon program this year due to the impact of COVID-19. As the situation continues to change, the safety and health of our Shell Eco Marathon participants and our organizing teams remains our top priority. And given the current situation, we are really excited to have you all with us today in this new digital environment to kick off our virtual learning sessions from the safety of your homes. So today, you will be hearing from Eric Larsen from Altair Engineering about fast meshless analysis. Altair is a global technology company that provides software and cloud solutions in product development, high-performance computing, and data analytics. Altair supports Shell Eco Marathon by supplying licenses, training, and support for Altair HyperWorks to all teams that participate in Shell Eco Marathon. Eric himself, he's a technical account manager for education at Altair Engineering and has been working with Altair for over 13 years. He studied mechanical engineering at Michigan Technological University and has 30 years of professional experience in product design and analysis. So welcome, Eric, to the call, and we look forward to hearing from you in just a few moments. But before we go there, just a couple housekeeping comments here. We would like to make sure that this session, of course, is as interactive as possible. So if you have any questions throughout the presentation, please go to the website menti.com on your browser and enter the code shown on the screen below. On menti.com, you'll be able to post your questions, see others' questions, and give a thumbs up to any question you think are more important to answer, so we can raise them to the top of the queue. If by any chance you have an issue with menti.com, you can also post your questions in the YouTube right of the live stream once you're logged in to YouTube. Eric from Altair will then be answering your questions after the presentation. And let's make sure we give him some really tough questions, so we have to push his knowledge. This is your chance to ask whatever you wanted to ask. As you know, this is a live video stream, so if for any reasons we run into technical difficulties, please be patient with us and bear with us for a moment as we try to fix the problem. And that's pretty much all from me now. I'll hand you over to Eric from Altair, who will officially kick off the session. So Eric, here you go.
Thank you very much, Norman. I appreciate that kind introduction. So I just wanted to mention a little bit about our history with support. We're for Shell Eco Marathon. We are now in our 4th year of proud support and sponsorship with the Shell Eco Marathon, and happy to continue that relationship and looking forward to growing it in the future. But even before we began our formal relationship with Shell, we have long supported super mileage and really any competitive design team through providing sponsorship, mentoring, training. We also sponsor a vehicle design award and sponsor any competitive design team. With our CFD structural and optimization technologies, we're a great fit for any team that's looking to improve vehicle performance or any sort of improvement on their vehicle. We'd love to give you a hand with that. At the end of this presentation, I'll go through how you can achieve a free sponsorship through Altair, so we can work with you to improve your designs and help prepare you for a career someday. So with that said, I'm not going to bore you with any slides or presentation along that lines. Let's hop right in and discuss how to use SimSolid to improve your designs by running structural simulations. So this is the SimSolid interface. It's a very relatively simple interface, very easy to use. It is a preprocessor, so it's where we're going to set up our analyses, it's where we're going to run our analyses, and it's where we're going to post-process them to look at the results. So it's kind of an all-in-one interface. There are no capabilities for generation of geometry within SimSolid, so it does rely on a relationship with a CAD software. So the process is going to be, you're going to develop this, the geometry in a CAD package, and then you're going to test it here in SimSolid. And the strength of SimSolid is it is a truly meshless geometry-based analysis software that is going to give you results in an order of magnitude less time than it would take through a standard traditional finite element process. So let's get going. I'm just going to come up here to my project, and I'm going to import from file. So this is how we're going to bring geometry into SimSolid. So I come to import from file. You'll see we support all of the major CAD packages. CATIA, Inventor, Pro-E, SolidWorks, UG. Plus, Step and Parasolid as a third-party software or third-party format to bring in. So whatever format you have, we will be, or whatever CAD system you have, we're going to be able to bring in that software, that geometry. What I have here is a drone body, and this is a step format. I have this modified one. We'll get to that in a little bit, but I'm going to grab this drone body step, click open. It will read that in. That little slider will go across, and now we're going to get a top-down view of the drone body. But the first thing that's going to appear is this little connection wizard here. SimSolid is going to automatically connect your part together. So when you develop your geometry in your CAD package, it can be many, if not dozens, if not potentially even hundreds of individual parts. And one of the more time-consuming things in any analysis is making sure all of those parts are properly connected together so your entire assembly acts as one unified body. Well, SimSolid is going to do that for you. Once you bring it in, it's going to analyze the model, geometrically analyze the model, and develop some good tolerances here for gaps and penetration. So gaps are a separation between any two adjacent solids that anything below that, it will consider them something that needs to be connected. Anything above that gap, it will consider them as two independent pieces. And then penetration is if we have two solids that penetrate each other, that go into each other. If they are less than this tolerance, it will clean them up, and you'll get a nice clean connection between the two of them. If it's more than that, we can run into some difficulties, but really if it's more than half of a millimeter penetration, that's something that truly should be resolved in your CAD system. So generally, as long as you've got a good high fidelity, high quality CAD model, you should run into no problems here. And we'll just leave everything as standard. If you start to see some issues, we can do high or increased or high connection resolution. I have never taken it off of normal, and it has worked perfectly fine for me. So just make sure you've got good connected good high fidelity geometry, and you should be okay. So I just click OK, and it has now generated all those connections. And I can rotate my model and take a look here. And if we expand this connections, you'll see regular connections. And now all I have to do is click on them, and it will show me each individual connection that it generates. So it's looking for two pieces of geometry that fall within that little range bound, and it will connect them. So on this first connection, connection one, this kind of pink purplish piece down here is part of the arm of the drone. And this kind of yellowish tannish piece up here is the top plate. It is identified that they are within that bound, and these little red X's, little red dots indicate the connection. And I can go through and manually review all of these just to take a quick glance at it and make sure that I've got good connections between all of my geometry. So now I've brought the geometry in, and it's going to behave as one single body. And you'll see in the assembly here, this is actually made up of probably about 25, 30 different individual pieces, but now this is going to be one individual or one connected body and behave as such. A couple of other things, if I come up here to the settings, you'll see I have geometry import settings. This is where I can set the values of how it's going to bring geometry in. The resolution, standard, fine, enhanced, custom. What that's going to allow me to do is determine or establish how the geometry is going to come in, how it's going to define the geometry within Inspire, within SimSolid. I always leave it at standard, and again, as long as you've got good quality CAD geometry, it should come in fine. But one of the more important things here is you'll notice that we have this import materials. If your CAD package supports the assigning of materials, we can actually import them in as well as and along with the geometry. So I've got a step file. It doesn't have materials. So I'm going to have to assign them manually, but assuming you have a CAD package that does have material assignment capability in it, you should get that in as well. And I click OK. And we'll get back over here to this project tree in just a second, but want to talk about rotating, panning, and zooming the model. In SimSolid, the standard keys for doing that, or the standard mouse clicks for doing that, is the left mouse button is going to give me a rotate. And I always like if I'm rotating in this direction, I position my cursor over on this side. If I'm rotating in this direction, I position it over here. And so we can get a good kind of trackball rotation there. Holding the right mouse button down is going to give me my panning. And then I can zoom in and out with the scroll wheel. But also up here in settings, you will see we do have some mouse settings. It's going to show you what the default settings are for SimSolid, but in an attempt to make sure that the process is as seamless as possible, going from a CAD system into SimSolid, we allow you to change those bindings by selecting a CAD package. So now that I've selected SolidWorks, 3D Rotate is middle mouse button, zoom in and out, a scroll. So you should have a seamless experience jumping from a CAD package into SimSolid by changing the mouse controls. I'm going to leave it at SimSolid though. A few other things about the general visualization. So we have shaded, we have a wireframe display, and then also when we're in shaded, we can turn on or off the edge lines. I kind of prefer them off. But one of my more favorite modes is this right here. This will now color each one of the different solids, each one of the different parts individually, and it really allows me to just kind of get an idea as to the setup and configuration of my model, to see all of the different parts individually as different colors. It does not affect it at all. And in fact, I only do this when I want to take a look at it, because then when I start selecting things, I like to turn that off, because now orange, to me, that just looks like another part color. So I turn it off, but now I can distinguish between what I'm actually selecting. So, but that's a great view to have on to allow you to just kind of visualize your model. We can go to translucent, so that was going to allow you to view inside and see how all the connections or how all the parts are set up. And then finally, I've got this cutting plane. So when I turn that on, or clipping plane, when I turn that on, what I can do, it's positioned right at the top of my part. And if I hold my control key down and I use my scroll wheel, I can move that up and down and kind of take a look inside my part. Or with my control key held down on my left mouse button, I can angle that and then zoom in and out. I can position it. If you get it into kind of a weird angle you don't like, just turn that off, turn it back on, and it goes back to a nice default state there. A couple of other things. This right here is the box select. When I select that, I now can do a box select and begin to pick things en masse. It will grab anything that I managed to hit the centroid of that particular part. It will select that. One thing that I do like, let me get it at a better angle here, is it is cognizant, or it's aware of which direction you drag from. So if I drag my box from left to right, you see I come here, I pretty much grab everything that box is touching. But if instead I drag my box from right to left, it will only grab entities that are entirely within that box. So again, if I come left to right, I just want to grab these 4 bolts and the sleeves that go around them. If I come in this direction, you see I get all this other stuff. The top plate, the bottom plate, I managed to nick this arm over here. But if I come right to left, no matter what else I hit, as long as these are fully enclosed in there, I only get those bolts. And then finally, we have a measuring tool here. So with measure, I just do a distance here. I can come this point to that point, and it will tell me, okay, that's 167.815 millimeters. So I can get some quick measurements, some general idea of the size of my part. Okay, so that's kind of our tour around the top here. what I want to talk about now is coming into this display in here. So once I opened up that drone body, it created a project. Excuse me. And this entire thing falls under this project drone body. Some of our master things up here, I can define units. So if I come to units, I get this little ruler up here at the top. I can grab that. I am in SI units now, so everything is going to be in terms of SI. But even within that, I can now change the type of unit I'm going to use for, say, displacement. The default is millimeter, but say I want to work in centimeters. I can change the centimeters, and now if I were to come here and say do a measurement from here to here, it's still showing me millimeters. Why is it not updating? Centimeter, okay. Oh, maybe the measurement is going to show in the default or whatever the default was. But now values that I put in would can be put in as centimeters, or I could come in here and change it to meters. So I can change the individual input unit. Oh, I'm sorry, I probably needed to change the output. That's why it showed up. That was input units. I need to do output units. So once I change that, it will show the individual unit. I could also come here and change to IPS, and now I'm in the inch pound seconds system, and I can change those as well. But I'll stick with SI units and millimeters. Next, default material. I don't have a default material specified. I rather would take and define my material manually in this case because it's a very easy process. And to do that, I just expand my design study. So when I created the project by bringing it in, the very first thing it did was define a baseline. So this is my baseline model analysis. If all I want to do is this, that's fine. It's just an analysis. But where some of the major strengths of SimSolid come in is doing comparison studies or what-if studies, and we'll get to that. But now I come here to my assembly, and I'll expand that out, and you see I have all of the, excuse me, 25 or 30 different parts here. And if I click in here, it is going to highlight them on the screen, or if I highlight them on the screen, it will come and indicate in here as well. But nothing has been assigned a material yet. Once we have a material, it will show up next to the name of the part here. So when I'm in the assembly, I'm going to come here and I'm going to select apply material. And with my material open, I can see the entire library of materials, and there's quite an extensive library here. And I'm going to select ABS plastic. We're gonna imagine we've 3D printed this drone body. Once I select ABS plastic, it's going to show me all of the values for that. And then I can come here and click apply to all parts or apply to selected parts. So I'm going to click apply to all parts. And now you'll see over here in the assembly window, it shows the part name and then the type of material it's made out of. But in conjunction with that, I could come here, I could come to my box select. There it is right there. And I'll do my right to left. Grab just those right there. And now I can come to my materials. And maybe I want to make these stainless steel. And then as opposed to apply to all parts, I apply to selected parts. And now just those have become stainless steel. I need to expand this out to see here. There's a really long name. There we go. So stainless steel 302 annealed. So I have the ability to define materials en masse, or I can do the entire part and then grab selected things, and we'll get into another case of material changing a little bit later. But now I'm all set. I've got everything ready to run an analysis. I just have to now define the type of analysis I want to do, and that's going to be defined by these icons right up here. So I've got a linear structure, I've got modal, I've got dynamics, I've got thermal, and then post-study. But I'm going to come here to my linear structure. I'm going to come to structural linear, and we're just going to do a quick linear static analysis on this. Let me turn off my box select so I can rotate. And now I have this here. I can come to my structural, and now I have all of the different parameters that need to be set up or can be set up for a structural analysis. My immovable supports, my sliding supports, hinge pivots, springs, pressures, forces, gravity, inertia load. All of these things can be applied to here. So what I'm going to do is I need to ground this. So I'm going to come to my immovable support, and it opens up this little window here. And this is now how I can pick the geometry that I want to apply that support to. And I have the ability to apply it to a face, an edge, a vertex, or a spot. I'm going to leave face, and I'm going to spin this guy over. There we go. And I'll just zoom in here, and I'm going to pick these bottom feet. So I'm going to grab this foot here. It shows up in my little window here. Grab this one. Don't worry about the fact that that's no longer highlighted. It just shows the immediate one that you've got highlighted, but the fact that it remains in there is what I'm concerned about. So I'm going to pick each one of these. Now they're in there, and I just click OK, and it goes and adds that immovable support. So these little white or these little yellow X's, little checks there, show me that it is now supported on the bottom of this. So no matter what I do, those are locked in place. And I'm going to now add a force. So to study this, I want a force applied to this. So I'm going to come to my force displacement. Try that again. There we go. And I'm going to say force displacement. And again, I can apply this to a face, an edge, a vertex, or a spot. And while you can't really see it here without there we go, turn the edges on, you see I have this little outline there. So that's going to represent maybe the electronics, some sort of package, could be the camera, something mounted on the top of this. And I want to see the force of this pushing down. So I'm going to change this to an edge. I'm going to pick that edge. And then all I have to do is specify the force that I want to apply. Looking at my triad down here, I can see that's in the Z direction, the negative Z direction. So I'm going to come to my force, and I'm just going to put in negative 100. And it tells me right over here, so I always know what unit I'm putting the force in, negative 100 newtons. Click OK. It doesn't look like anything happened, but if I peek inside here, because those forces are pointing in the negative Z direction, the arrows are going down. And now I have my supports holding the bottom. I have my forces pulling down on this. I'm ready to run the analysis. Everything is all set, and I can come down to this icon right here and click solve. Now, had I not been talking through the entire thing, I could have had this set up in literally a matter of a minute or two. And now you'll see where the true amazing power of SimSolid lies, and that's the solve. When I click this right here, it's going to go through, it's going to process everything, and we're done. That's it. The analysis is complete. That quick. And if I take a look at the info here, that took 7 seconds to run. Pretty impressive for a structural analysis. From all that we've taken into account that in a standard process, I'd have to go through, I'd have to model the thing, or mesh the thing, I'd have to set up all the materials, I'd have to do everything. 7 seconds plus the minute it took me to bring the model in and set everything up. To have a structural analysis and an accurate structural analysis done in a minute and 7 seconds with only 7 seconds solution time, that is absolutely amazing. SimSolid is geometry based. It's based on, or it's derived from finite element method, but it is purely geometry based. There is no mesh on here. And so now from here, now I have a result. All I have to do is come down to my result plot and indicate the type of result I want to show. So I'll grab displacement magnitude. It's going to give me a nice colored plot there, contoured plot. It'll give me a legend indicating what those colors apply to. I can click the play button so I can see how this part animates now. And we automatically scale up the animation. That is not the true one-to-one scale. In every case, whenever anyone's doing an analysis of this sort, they always scale it up because they want to see the general behavior of it. So we take care of that for you. But all I have to do is come here to my change max deformation. I can actually use this slider to increase or decrease the deformation scaling. Or if I click this little selector there, now it's showing the true deformation. And if I zoom in here, I really have to zoom in quite far to see that thing deform, which is why we automatically scale it. But we can always check by checking that box there. I also have the ability to change how it is colored. I can do a 6 color, get more discrete. I can do a 12 color, or I can do a smooth color where we smoothly contour from one color to the next. I prefer the 12 color myself. I can show min and max labels, so I can see where the min and the max deformation are. And anything I do here, so I'll leave those on. Once I've got it all set up, I'm going to come down to this little camera here, and I'm going to create what we call a bookmark. Our bookmark, if I select it, say I change now to von Mises stress. I'll turn those labels off. If I come and select the bookmark, it will take me back to the exact setup I had, which is useful. But the true power of the bookmark is going to come when we start looking at alternative designs, and I'll show you that. So I'm going to bookmark my my stress as well. So there we go. Okay, perfect. So I got my 2 bookmarks. I've seen my results here. And that's it. I've done my static analysis. We'll move on to another couple of analyses, but just let me remind you that if you do have any questions as they arise, please don't hesitate to go to menti.com. And if you enter the code, it just appeared there at the bottom of your screen, 572392. You'll be able to ask questions, and I look forward to, when we're done with this, dealing with all of your questions and helping you out understand how SimSolid can help you. So please don't hesitate to ask any questions you have as they come up. Okay, so I'm going to leave my contouring here. We're going to go back to my main display, and I'm just going to take my structural. I'm going to tuck it back in by reducing that, closing that. The structural is always there, and it's bold, so that means that it has run and it has results. But the next thing I'm going to do is I'm going to come up here, and within this same design study, I'm going to add a new analysis. So I'm going to click modal. Now it has gone and put modal in there. The number of modes defined, I click 9. So I'm going to get 9 modes, and I run it. And as quick as that, now I have the modal results. And this one took 3 seconds. So I now have my modal results. I can find out the frequencies that this wants to vibrate at. So I highlight my result. I come here. I will go to energy or displacement magnitude, and now I can see. Let's turn off the legends. Now I can see the first 9 frequencies. Now, because this was unsupported, this was a free modal analysis. The first 6 frequencies are rigid body modes. They're always 0 or very close to 0. So we ignore them. The 7th, being the first important one in SimSolid, is smart enough to know to ignore those first modes and start off with the 7th. So I can see that, what are we at? 8.7986 e to the 1. So we're at about 87, just under 88 hertz for our first natural frequency. I can animate that and see how it vibrates. So that, that makes sense to me. Come to the second one, now we're getting that up down. Come to the third one, we're getting a reverse of the first one. And had I asked for more, I'd get more and more complex shapes as these increase. And since I'm relatively narrow band here, I probably would ask for more than just 9. But now I have my frequencies. Next, why don't we toss another one on here? Why don't we do a thermal analysis? So I'm going to come here. We'll do a thermal analysis. And again, once I add that, then I get my my different types of loads I can put here. So I'm going to come to temperature, and this is just going to be a straight temperature load. I'll put it on that face right there. We'll say our electronics are getting pretty hot. And so we'll say 100 C. So that's just a straight temperature load. And then maybe down here at the bottom, maybe we have a flux going on. So we'll do our flux here. We'll grab that face, and we'll say that this is taking away 50 watts per meter squared. Whoops, sorry, taking away, so negative 50 watts per meter squared. Click OK, and now I get my indication of my flux. So I could go through and add all of the different temperatures, any fluxes that are going on. And as soon as I've got that set, just come here, click solve. And as quick as that, I have my thermal results. And I can take a look at those. We'll do temperature. So there's my temperature. And I can see how that is affecting the part as well. See the thermal analysis from this. And again, everything is nicely saved under this baseline study. And I have all of the information I want, and I got it very, very quickly. But now, this is where the true power of this. Everything up to now was very powerful, but this is where the true power of SimSolid comes in. It's studies on modifications, what-if studies. So I'm going to come up here. I'm going to say project import from file. And I'm going to come to my drone body modified now. And I'm going to click open. Now, unlike when I imported the first one and it created an entire project out of it, now it has recognized it to add a design study too. And I get that automatic connection wizard. So I'll click OK, and it's going to go through and it's going to do the wizard on that and create all my connections. But you'll notice with my design study too, I have my structural, my modal, my thermal. It has recognized that this is very similar to my initial design study. It realized the similarity there. So it went and applied everything that it had from the initial study to this study. In fact, the only thing I have to do is I need to come here, and you'll notice that these arms, so the difference between my two studies is I decided I want to see if I can make this a little lighter by making these arms a little thinner. This was what it was initially, and I thinned those out a little bit and cut down my motor mounts. See if we can make this a little lighter. So the only thing it didn't do is on each one of these arms, it didn't assign, and the feet, it did not assign a material to them. And the reason for that is because they were modified. It doesn't want to make assumptions. The parts have changed. So what I'm going to do is I'm going to come here. I'll do a box select. I'll grab these, and then I'll do a control to box select that as well. I'll come to my material. I'll come to plastic, ABS, and I guess I could have applied to all parts, but I'll apply to selected, and now we've got the ABS plastic for those, and everything's set. Literally as, oh, sure, absolutely. I apologize. Appreciate the input there. Yeah, I'll slow it down. So all I did was bring it in. I altered or changed the materials for that. And since the design study is exactly the same with the slight modifications as the original one, it has gone and it has put those analyses in there. And all I have to do is select them and click solve. Now my structural is done. My modal is done. And my thermal is done. Now I have exactly what I have up here, but with the new design. So I can come to my structural, and I could contour the results, but if I come to my bookmark and open up my bookmark here, it's going to show me my initial results. And now if I come to my, come to my bookmark, and come to design study 2, click result, it's going to take the exact setup that I had for my initial design study, and it's going to put the new results into that exact framework. So however I had it oriented, any changes that I made to my results here, I now can view my new results as a direct comparison to my original. And all I have to do is switch between them, and I can see the exact results. So you can see I went from initially a 0.52 millimeter displacement to a maximum of 2 millimeter displacement, which, of course, I would expect considering the change in the thickness of the arms there. If I come to my modal, I can take a look at my modal results, and I can take a look at my thermal results as well. So with almost no input whatsoever other than to come and assign the materials to the new assembly, I was ready to run the new analysis by just selecting run. And as it was mentioned that I may have gone a little bit too fast in that regard, let me go ahead and do that again. The way that I assigned the material to those was I came here to my assembly, I went to my box select, I box selected that, I held my control key down, and I box selected those, went to the materials, and came to ABS plastic, and I applied to just the selected parts, not to all parts. So now I have my design study 1, my baseline, a design study 2, and you can see I can tuck them all in there, make it a little cleaner. But I've determined, or I've learned from my design study 2, that perhaps switching to a thinner arm may not have been the best choice. I'm getting a bit higher stress. I'm getting much more deformation. So maybe I want to do a what-if study to see if I change the materials for those arms. What effect would that have? That might be a bit of a process in a normal analysis tool, but within SimSolid, all I have to do, come to my design study 2, right-click on it, select copy, and as quick as that, I have an exact copy of design study 2, now called design study 3, and I could come here, I could pick this arm, control, 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 click those arms right there, come to my, oops, I guess I had to be in assembly first, I apologize. Select that, control, 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 come to my material, select my materials here, and we'll go wild, we'll make them titanium. And now, as opposed to all parts, I apply to selected parts, click OK. If I take a look in here, you'll see that those arms are now made of titanium. The entire rest of this is made out of ABS plastic. And all I have to do is come to structural and run that analysis again. Come to modal, run that, and come to thermal and run that. Come back here to my bookmark. So originally, my deformation was 0.52 millimeters. With my second design study, when I made the arms thinner, that jumped up to 2 millimeters. And with my third design study, where I went and changed those to titanium arms, I'm actually below my original design, which had the thicker arms, and I'm at 0.49 millimeters. So I've reduced it. So I've thinned those arms out, and by making them titanium, I was able to reduce the overall deformation, the overall displacement. So you can see what-if studies, insanely easy to do, quick and very easy to do. All I have to do is, if I have modified geometry, come up and import that in, and as close as it is to the original baseline study, it will take all that it can and transfer it to the new body, and then I just have to assign anything that wasn't assigned. And then doing a what-if study on the changes that I've made, it's as simple as right-clicking on here, clicking copy, I get a brand new design study, and I can make any changes I want to that without affecting it. And all of this information is saved when I come here and say save project, name it drone body. All of that information is saved in that project. So a day, a week, a month from now, if I want to see my results again or do another what if analysis, I just open that project. Exactly as I left it, it's all right there. And I'm ready to go again to see what changes or what effects any changes I want to make will make. And again, please, if you have any questions whatsoever, please go to Menti, menti.com, 572392. It's right there at the bottom of your screen to ask any questions. I'd love to field any questions that you might have. But from a basic usage standpoint, this is pretty much how easy it is to use SimSolid. I think we've covered just about everything that you would need to get to hit the ground running, to do analyses, sometimes even complex analyses, or do what-if studies, comparison modification studies on your geometry. I've been asked in the past with a software like this, what kind of industry integration do we see? Are companies actually using this? And without question, the answer is yes. Industry is embracing this. I've taught many classes to industrial partners, industrial customers of ours, and they are embracing it. In fact, it ends up being one of the fastest, if not the fastest growing software in an entire suite of software tools, because of the ease of use, because people can very, very quickly adopt this. Just as a quick explanation, without getting into details of who it was or what it was, a customer of ours, they were doing modal analyses on very, very complex parts. They'd bring them in, they'd spend hours refining the geometry, and then 13 hours running the analysis to get a modal analysis. With SimSolid, it took us zero time, or just about a minute or two, just to bring the thing in and assign the materials to it. Didn't have to do any geometry refinement, and it took about 16 minutes to run the modal analysis. So from about 17 hours down to 16 minutes. But what I'd like to share with you is what we call a success story. So many of our customers are so pleased with the results that they're getting from the software that they have. They volunteer to do a success story. It basically tell their story, brag about the success that they have. And a customer of ours by the name of Don Burr was able to utilize SimSolid, and they want to share their results with it. So why don't we take a couple of minutes and just see the results from that in a video, and just give you an idea of how industry is embracing this. When we're done with that, we'll come back and I'll show you how you can get your hands on this and all of our software through a team sponsorship. So enjoy this 2-minute video.
We are manufacturers of commercial vehicle bodywork, and what that means is that we design and manufacture from scratch semi-articulated trailers and the bodywork that fits onto rigid chassis. We are known as the innovators in the industry, so we continually have to push the boundaries of what we can produce for our customers. Our engineering team, all of which using SolidWorks as a core engineering product, use simulation on a reasonably regular basis to be able to test out various different types of product. I think some of the problems that we've had with the SolidWorks package inherently is the time spent to be able to set up the models and the simulation runs. And not just that, it's actually the running time itself. So the way in which even the most powerful computers that we can invest in still have difficulties in being able to process those meshes and being able to process the models that we're running through them. The team's first impression of SimSolid was disbelief. And some of the claims were really a bit fantastical, and I think to a large degree we wanted proof of that. We needed to be able to assess the software and go forward from there. And it was staggering. It was staggeringly fast, both in terms of setup and in terms of processing. A good example of the time difference would be something like an underrun bar, or what general people might know as a bumper. And effectively we're testing the stresses and strains on impacts and various different twists in the chassis. So typically on SolidWorks it might be a setup of approximately half a day roughly to be able to process that. And the actual processing time to be able to run the simulation might be in the region of maybe 2 to 3 hours. So in contrast to that, SimSolid might only take half an hour to an hour to set up in the first place, and in terms of processing time, it might take 20 seconds to run that software and be able to provide the kind of solutions that we're looking for. So there is a marked difference, fantastic difference. We took the SimSolid results and were able to submit those results to the DVSA, who then physically tested it, and we found that they were within approximately 1 millimetre of the deflection that had actually happened. So it was a really, really good tool for us. We certainly wouldn't stop using what we've already got. It's inherent with the way that we do things. It's inherent with other product suites that we have on site. So we wouldn't be able to turn away from it. But the SimSolid software has been able to act as a bolt-on. It's a very simple bolt-on, and the integration has been seamless. SimSolid has been able to release resources that we would have otherwise spent on different projects. So what we're able to do is reallocate those resources so that it's more effectively used on other projects. But what it really means is the fact that we can expand on that investigation for a particular sub-assembly, for instance. So if we look at a lifting deck, for example, it's not restricted to running maybe 1 or 2 different scenarios. We can run multiple scenarios on multiple different products to try and find the best possible solution for our customers. I think my response to other companies who are considering using SimSolid would be that we found it quite a staggering product. We were quite surprised, or significantly surprised, at the results that came out. And I think we would say to anyone else that was considering it, you really do need to evaluate this product. It does offer real value.
Excellent. So I wanted to share that with you because I know, especially when we're talking about kind of a revolutionary new technology that people aren't familiar with, it's always nice to hear that somebody else is using it successfully. And especially, one of the things I liked especially about that video was when he said that they did their testing and then they had it physically tested and the results were within 1 millimeter. That just kind of gives you that comfort and that ability to trust the software. So again, I just wanted to share that with you so you know that there are corporations out there using it, they're seeing success with it, and they are trusting the results in their analyses. And as he mentioned, they've got tools that they're using already. They're not looking to abandon those tools, but this was a nice addition to it, addition to the tool belt, addition to their suite of capabilities of analysis. A bolt-on, I think he referred to it as, is the another software in their suite of tools that they use to analyze it. So now the big question is, how do you get your hands on this software? And I'll tell you, it's frighteningly easy to do. So all I need you to do is go to altairuniversity.com. I've got that up right here. You'll see the biggest, most prominent thing on here is the free student edition, and that is great. The student edition is wonderful. It's free to any student as long as they're registered in a university, or even second or high school students. We've supplied it to them as well. There are a few things about the student edition. It is not our entire suite of tools, and SimSolid is actually one of the things that's not included in there right now. The only ability for anyone outside of a team sponsorship to get SimSolid is through a 15-day trial. And there are some of our software does have limited or does have some limitations. Inspire is not one of them. Inspire is the free or is the full functional. But some of our other softwares have some restrictions on them. So Student Edition is great, but what I want to direct you to is a team sponsorship. And to get a team sponsorship, you're going to come to the students here. And under students, we've got some great ebooks that you can download on a number of our topics. There's some learning capabilities, learn from users, some project capabilities. You can look into becoming a student ambassador, get some benefits from us and help us promote our software. But if you come here in online learning and certification, but if you come here to student competitions, and you'll see Shell Eco Marathon is highlighted there. We're very proud to work with them. request sponsorship. And this is all you have to do. Fill out this little form here. Usually it's done by the team liaison or the team president or team captain. Very simple form to fill out. You're going to fill that out. We're going to get in touch with you and make the arrangements to get that sponsorship going. Our sponsorship consists of a full enterprise level corporate license, the same license that we give to our corporate customers, and we'll give you as many copies of it as you need. You have one person, two people, three people, 20 people on the team who want to use it, and they will give you that many licenses. Plus, we'll give you the support, we'll give you training. Oftentimes, we can come out and visit to do in-person training, to do mentorships, help you out, use the software, use this and any of our software, because every single one of our software packages at Altair is available through that team sponsorship. I say it's an application. It's not even really an application. It's more like you're signing up. There are no restrictions to getting a sponsorship for a team. You just have to be a team. And then the only restriction then becomes you have to agree to use it strictly for educational team-related purposes. But other than that, everyone gets it, and we love to help you out. We'd love to bring you into the Altair fold and help you utilize software so that when we do ultimately get back together, hopefully next year in person, the vehicle you're going to roll out is even better than you imagined it could be. And with that said, I'm going to throw it back to Norman, who's going to bring the segment that we like to refer to as "Let's Try to Stump Eric." I'm sure you guys have posted some absolutely phenomenal questions, and I look forward to hearing them. So, Norman, back to you.
Yeah, thanks, Eric, for the wonderful presentation and for the hands-on tutorial that you've given us. Very insightful. So please, everybody, this is your chance. Pass the questions or send them to menti.com and let me pass them on to Eric to give him some really tough questions. This is your chance to ask. Send them through menti.com. You find the number on the bottom of the screen, or just type them in the YouTube comment box. If there's anything you want to know. Eric, I think first and foremost, can you tell us a little bit about what is the difference between SimSolid and Inspire that we've heard from you yesterday, and when should I use what?
Excellent question. So as with many of our softwares, there's often a bit of overlap. There's things that SimSolid can do and uniquely can do. There's things that Inspire can uniquely can do, and there are overlaps between the two. The choice of the software that you use is sometimes dependent upon what you're looking to do, and sometimes dependent upon just comfort and feel with the software. Inspire does have the capacity to do optimization analysis, which SimSolid can't, and it has the capacity to do multi-body dynamic motion analysis and couple that with analysis, structural analysis and optimization, which SimSolid can't. SimSolid, on the other hand, has the capacity to do more advanced thermal analysis. With Inspire, we're just doing heat as a load, whereas SimSolid is actually doing heat. You've got flux in there, and so we can do thermal analysis, thermal flow analysis. SimSolid does do frequency responses, some of the more dynamic analyses. But then there are things that both of them do. So from a structural standpoint, both Inspire and SimSolid do the same thing. And there are people with a comfort level with Inspire that they like to stick with Inspire. But you'll also notice that with Inspire, sometimes it can take 2 to 3 minutes to run an analysis. But I will tell you, or sometimes even more, that you can go into Inspire and you can switch the solver mode as long as you're using the latest version of Inspire, which you would get with a team sponsorship. You can switch the solver mode, solve with SimSolid instead of OptiStruct, and then you get the interface, the convenience of the interface in Inspire, which a lot of people like, with the speed of processing of SimSolid. So we can even cross over between the two. but then you would be limited to just doing structural analysis. If you wanted to do optimization, you'd have to flip back to the OptiStruct solver. So hopefully that was comprehensive enough to answer the question that was asked.
Yes, thank you, Eric. And next question about the software itself. Can you show us how you can insert custom materials other than the ones that are in the default library?
Excellent. Okay, so let me come into here and go back to my software here. So if you come up to the settings and you come to material database, I can just edit the current material database, and I would come into here and let's come in. I come to one of the groups, so I can add a new group, but we've got the standard groups in here: generic materials, plain carbon, stainless steels. So what I would probably do is I'd come here and I'd add a group, and I could rename that group to whatever I want, and then I select that group and click add a material, and then all I have to do is come down here, give that a material name, enter in the elasticity, module of elasticity, Poissons, all of these values here. I click, so I'll just put in some dummy numbers here. Please forgive the fact that all of these make no sense whatsoever. I'll call this dummy material. Oops, help if I spelled it right. There we go. And click save. Poisson's ratio is out of range. Of course it is. So SimSolid is smarter than I am. It knows that I put in an absolutely ridiculous number there. So now I've got dummy material, and you'll see if I come back to my model here, I come to assembly, and now I have material group 0, or I could have renamed it to my custom material group, and I've got dummy material, and I can apply that as well to there. So you can see it's very easy to add material to the database as well, as long as you have all of the parameters for it.
Mm-hmm. You referred to between to first and second design. Can you repeat the difference between the first and the second design? What did you mean?
Oh, sure. Yeah, absolutely. So I'm going to come back to the software here. So when I was working with this, in fact, let me do this. I'm going to say close project, and I'm just going to open up my. Oops, no, sorry, not open. Import from file. I'm going to import my original drone body step, and just make the assumption that I went through and did all the things to run the analysis. I set up my analysis, and then what I wanted to do was I made a change to this. So in my CAD geometry, I don't have the ability to edit the geometry here in the SimSolid, but I ran the analysis on this. I was comfortable with my results, so maybe I felt there was an opportunity to save a little weight by making changes to these arms here. So what I did is I came here to project, import from file, and I imported now in my modified geometry. So in my CAD system, I altered my geometry, I changed something in it. I'm going to import that in. And now that's going to bring my modified geometry in. And you'll see here that this is my modified geometry. That's my original geometry. So I've thinned those arms out. And if I now reopen my project, the great thing about SimSolid, or one of the many great things about SimSolid, is when I had my baseline study with the thicker arms, and I imported in my secondary design study with the thinner arms, because the rest of the geometry was exactly the same, it was able to, without any input from me, to transfer over all of the parameters for the structural, the modal, and the thermal analysis. So I didn't have to set anything up other than to come to the arm and the foot there on each one of the 4 arms and feet and assign the materials to them. Since the geometry had changed, it didn't make any assumptions. It did not assign a material to them. I had to come in and manually assign that material by selecting them and then coming in and assigning the material. Then when I went to design study 3, when I wanted to make these titanium, I didn't want to disrupt the work I had done on 2, so I just right-clicked on 2, clicked copy. That added a new design study. I came down to the arm, I'm sorry, came down to the arm, selected material, and changed that to titanium. And then I had a brand new design study. And I can keep either importing geometry that I changed in a CAD system, or I can right click and copy and make changes to parameters within SimSolid. That's the difference between the original design and the second design, and then ultimately the third design.
Mm-hmm. And another question related to this, is there a way in which you can show the results of all the different studies in a single overview, like an overall result?
Not that I'm aware of, but that doesn't preclude the fact from it actually existing. I tell you, all of our softwares, and I've been using our softwares for a very long time, all of our softwares, I tend to always learn something new about them every time I talk to somebody new. So I will say I don't know of a way of doing that, but just take a quick look around here, see if there's any way that that I can see. What's this? No, that's a response. So I'll say I don't know, but if you want to drop me an email, my email address is Erik, ERIK, at Altair.com. So whoever asked that question, if you want to drop me an email so I know how to get back in touch with you, I will track down the developers of SimSolid and find out if there's a way to do. I know exactly what you're asking. Find out if there's a way to do it, and if there's not, I will absolutely pass that on to the developers as a recommendation for something to add in the future. So drop me an email and I'll take care of that for you.
Thank you. And again, a reminder, we're on top of the hour, but we have a little bit time left. If you have any questions, this is the chance to ask now. Type them into menti.com or in the comment box on YouTube, and I will pass the question on to Erik. So if you have any question for him, please ask now. Another question that's come in is there any particular reason for the original model to be on a step file format?
Other than the fact that I took this model from Inspire, it's actually one of the models that we use in our Inspire training class, but I liked it as a demo model for this. And the only thing that Inspire can export geometry as is either parasolid or step, and I just happened to randomly pick step. So there was no specific reason other than that. The one main reason why somebody uses a parasolid or a step is, well, one of the two main reasons. The first main reason is there oftentimes is a little bit of a lag between one of the CAD companies releasing or providing a new release of their software and the time that our software supports that new release. Unfortunately, we don't get any advanced knowledge of releases or kind of advanced info from the CAD companies. So when they come out with their next point release or major release, we get it at the same time, and then we have to start updating our library so that we can support the import of that. So that would be one time where we'd have to use an intermediate format. The other time is a lot of people will release a file to Step or Parasolid just because they don't know necessarily who's going to be bringing it into what software, and not all softwares support the importation of native CAD data, and it just saves them having to come back and ask for the step or parasolid. So if you really don't know where the ultimate destination is, a lot of times people will choose step or parasolid. And between the two, step or parasolid, they're both equally capable. They're both good intermediate formats.
Mm-hmm. And somebody's asking, is there a difference in accuracy of the results between Altair Inspire and Altair SimSolid?
There's always going to be a little bit of difference. In general, analysis as it is an approximation. And so whether we're comparing Inspire to Abacus, to Dyna, to SimSolid, to any other solver, there's always going to be a little bit of a deviation, usually within a few percent. So never is it exactly the same. But I'll tell you, in every case when I've run an analysis, the results have always been literally a few percent of each other. And when it comes to finite element analysis, in general, we're always expecting an error range of about 5 to 10%. If we're within 5 to 10% of our expected results, we consider that a good run. So the differences between the two softwares are well within the accepted range of error, of deviation in a general finite element analysis. So FEA is an approximation to begin with, and the fact that we're within just a few percent, as far as I'm concerned, essentially says they're giving the exact same result.
And we have some interest out there. How does the solver work?
So, unfortunately, I can't tell you that, not because I'm trying to keep a secret from you, but because I just don't know. The people who have the mathematical capabilities to develop these solvers, they are far, far smarter than I will ever be. But I will tell you, it is based upon FEA. It's using generalizations of finite element method. So they have taken, my understanding, a very limited understanding of it, is they have taken the concepts of finite element analysis, and they've developed geometric generalizations from that to then be able to predict from a geometric standpoint how it's going to work. So it is based in solid FE theory, and then they were able to make generalizations. I know it's a number of different processes they use depending upon the type of geometry, but it is 100% rooted in tried and true FE theory that then allows us to make the generalizations on the geometry. Beyond that, even if I understood it, I probably couldn't tell you anyway because I don't think they'd tell me. So
we have another question here. Can I set a time for which the force is applied and if it can be ramped, or the impact, and check the deformation at each time step?
Yeah, I didn't get into kind of the transient dynamic analyses, but we do have the ability to do a transient analysis. I honestly have not done one within SimSolid, so I can't talk intelligently to it. But one of the options along the top bar is for a dynamic transient analysis, and that does include time. So one would assume, and I can't speak 100% to it because I have not done it, but I've done transient analyses in other softwares, and yes, you can ramp it up. I would think you could do it in SimSolid, but I can't 100% attest to that. You would have to check into that. And again, you can always, I gave my email earlier, just my name, eric@altair.com. You can always drop me a question, and I can pose the question to some of the developers, and they can get me that answer, and I can get it back to you. So.
No, thanks. And before I let you go today, there is a final question, and that is probably relevant to all of us using the software. How do I know my solution is correct?
Excellent question. So there's this concept out there that I've always kind of held true to, and it's the idea of trust but verify. So any company that is producing a finite element or geometry based any company that's producing analysis software, one of the first things they're going to do is they're going to base their mathematics on tried and true mathematics that are the math that works if we could do it by hand. But then what they're going to do is, I believe it's NAFEMS and a number of other companies out there, the standards companies, have what they call confirmation models or benchmark models. And they are models that they 100% absolutely know the correct answer, whether they've derived it by hand, by testing, a combination of both. They have these models. And what you do is you put those models into your software when you're developing a new software, and you verify that the answers that your software are getting is the same as the tried and true results, the results that everyone knows. And there's a number of different models that use a number of different techniques. And as long as you can prove that your analyses meet those, then you can develop a level of confidence in the results that your analyses are getting. But that doesn't stop there. We're always confirming the results that I get. We never just rest on our laurels, and I would assume all FE companies are the same. We don't rest on it. We continually check. And from a personal standpoint, and I've mentioned this before, trust your gut feeling when it comes to an analysis. Every analysis that I've run, and most people, I would assume all people are the same. Every analysis that I've run, I've never gone into it blind and said, you know what, I don't know what this is going to do. I always kind of have a feeling as to what I'm expecting out the other end. And my feelings are always usually relatively good. And when I get my results back, a lot of times they're just kind of confirming the feelings that I had and giving me specific numbers for it. But occasionally I'll get a result that's like, whoa, I was not expecting that. And if that's the case, trust yourself. Don't just blindly follow the software. If it's not agreeing with what you thought, go and check your model. It's really easy to make a mistake when you're setting a model up. We use very large numbers for Jung's modulus, for instance, which sometimes are even as high as e to the 9. That's a lot of zeros. And it's really easy to leave one off. And if you leave one off, that's a tremendous error that can be produced in there. So get an idea. You've got an idea is what you're expecting. If you're not seeing that, check your model. If your model checks out and you set up everything right, well, many times I've been surprised. But then I just say, okay, yeah, it was something different than what I thought. But I can tell you, our codes have been verified. We meet with the requirements. We verify against known models. They work, and I was skeptical. The idea of SimSolid, it was a paradigm shift for me. It was taking me away from what I was used to doing. I've been doing FE for decades. And I checked it, and the numbers came out correct. So,
thanks. And there's a last-minute question that just slipped in, and I'll be happy to ask that as well. And is the program, is the software able to perform composite material analysis?
Not as apply layup. So a composite obviously is a layup of but we can't do it as apply layup. You would have to homogenize it, come up with a general structure. We are limited to isotropic homogeneous materials within SimSolid, so you'd have to kind of take an estimation or derive an isotropic behavior of the material to be able to test it, and then use that as the basis for forming your composite material.
Thank you so much, Eric. I think you've done very well. You fielded a lot of questions. You answered all the questions that we had out there. So thank you very much. And a huge thanks to all of you. This wraps up our Shell Eco Marathon virtual learning session with Altair now.
Norman, can I just, I just received a memo that I just wanted to insert in here before you wrap things up. Just wanted to mention that NAFEMs, they're the ones who provide the models for verification. They actually did an article on SimSolid in January, and they mentioned that they were, and they quote, very happy with the result accuracy from SimSolid. So the group that does this sort of verification, they have confirmed that the SimSolid results, they're, as I quoted, very happy. So I apologize for interrupting. Just wanted to get that in since the question arose before we officially sign off. So.
No problem at all. Thanks for clarifying that and for adding that in. Again, my thanks to you for answering all these questions so expertly. And thanks to everybody for joining us today. This wraps up the Shell Eco Marathon virtual learning session we had today with Altair. There are more virtual learning sessions to come in May. The first one already tomorrow, where we will be hearing from Paul Over, who is a student of Hamburg University of Technology, as well as an Altair student ambassador. He'll be talking to us about lower energy consumption and better performance with optimized aerodynamics. So if that is not a topic for Shell Eco Marathon teams, I don't know. If you haven't registered for that webcast already, please do so on our website. We'd love to have you join as well. Also, I should say, if you want to watch this webcast again, there will be a recording made available and sent to you. Please also share that with your team members who couldn't attend today, or with other friends or colleagues you have at your university who might find this webcast useful. That's all for today. Thank you very much and goodbye.